Hey everyone, assuming this works, welcome to Open Space for Monday, November 23rd, 2020. Once again, this is my live QA where you can ask me any questions you want about space or astronomy or anything, although I don't have answers for anything else. But yeah, so go ahead, post a comment in the YouTube chat, and I will get going on that. A little housekeeping before we actually get on to the question show and give you a chance to put all your questions in. So we had to cancel last week's episode with Chris Carr because my power went out for a whole day. We went crazy. You realize how much you are dependent on internet and power when it goes out. Went out on, let's see, was it Tuesday last week? And yeah, it was Lord of the Flies around here. So it was pretty funny. My son read a book. He read a whole book, which was great. He read what did you read? Old Man's War. That's right. He read Old Man's War, which is a great book. And I read a bunch of stuff, and then the internet went out, and then I went for a lot of walks. We just waited. It's crazy. 12 hours of no power. I bought another UPS just to try and get a little bit more power. Yeah, Zapfan saying, like, jerry rig power from the leaf. I wish. I should be able to just plug my car into my house and have backup power. But yeah, Arjone, sounds like the power should go off more often. It's a funny thing. Like, try it sometime. Just shut your power off, shut your internet off, and just watch what happens to your mind. And you realize how completely addicted you are to this thing. We were like holding our phones up in the air and trying to because we have terrible cell phone connectivity from my house. And so I went for like a bunch of walks so I could just get a little bit of work done to manage the team for Universe Today. And then I would come home. And of course, normally I would just go to a coffee shop and sit down and work in the coffee shop. But thanks COVID, we can't even do that. So yeah, madness. Crazy. Anyway, so we had to cancel the thing with Chris Carr. So we're going to do that. We're going to reschedule that probably for next week. I've got a fascinating interview that's probably going to be coming up in the next couple of weeks with a writer. He's a biologist, but he's an astrobiologist. He wrote a book called The Biological Universe, and we'll be talking to him about, I'm sure we'll have an argument about where all the life is in the universe. So that should be coming up pretty soon. And apart from that, just got mountains of great stuff happening over on Universe Today. New episode of Astronomy Cast, great interview on the Weekly Space Hangout last week with the project manager of the Titan Dragonfly. So if you want to hear about the Dragonfly, check out the most recent Weekly Space Hangout. So we've got lots of good stuff come out and lots more good stuff coming down the pike. So, all right. Let's move on to the question portion of the show. Pikel Malmer asks, how much longer will the Earth be habitable? Now, so you have to kind of define what you mean by habitable. Now, we know that the sun is going to be turning into a red giant in the next, 5+ billion years. So we've definitely got a hard stop at the end when the sun bloats up into a red giant and maybe consumes the Earth. If it consumes the Earth, then the Earth is definitely toast. So we can definitely, put a really hard stop right there. But the reality is that the sun is heating up all the time, very slowly. And over about the next 500 million to about 1 billion years, the sun will get so hot that it will increase the temperature on Earth and get it to the point that all the water boils away and the surface of the Earth is parched and dry. And that has nothing to do with global warming. That's a long scale thing, not the short term that we're seeing right now. But yeah, so we're looking at about 500 million years to 1 billion years. And what's going to happen is that life will go in reverse. So about 500 million years ago, we got some of the larger animals, larger life forms, and to the kinds of, the vast variety of life that we see now. And then as the temperature goes up and up and up, then the size of the animals, the kinds of plants that can survive will change and simplify. And then eventually it'll just be bacteria living underground for the far, far future. So, and I know it's funny, right? Because we have this sort of existential crisis when we hear that the Earth is going to be, that we thought we had 5 billion years, but now we've only got 1 billion years. And you're just like, oh no, it won't matter to us, right? Obviously, we're going to be gone in 100 years. So, except for me, of course, with my robot bodies, but for the vast majority of life on Earth, we're not going to last that long, except for maybe blue whales. Anyway, so I always find it so funny when we sort of, that the fact that we've only got 1 billion years left sort of causes this existential crisis in people. All right. Let's move on. Ted Krause asks, the Great Conjunction is almost here. How long has it been since the all-planet conjunction? An all-planet, I have no idea how long it has been since we've had an all-planet conjunction. But a conjunction as good, because you can sort of imagine there's different versions of it. Like the one that's coming up, and this is important. I took this question not because I knew the answer to your question, because I want to just talk about the conjunction, which is in December, you're going to get Saturn and Jupiter so close to each other in the sky that they will essentially be visible in a single telescope eyepiece. And you'll just look in the eyepiece and you'll see both of them side by side, which has not happened for about 800 years. So this is big. But the part that's kind of crazy is that the planets are already, their moons are already starting to intermingle from our perspective as they're getting closer and closer in the sky, because it's only about a month away for this to happen. And so pretty soon you're going to look and you're going to see some of the farthest to the left moons of one planet overlapping the farthest to the right moons of the other planet. It's going to be kind of crazy. So it's a pretty special time on what's happening. People are going to freak out. People are going to get really excited about it. And I've been excited about this for years now. And of course, as we get closer and closer, we're going to try to reveal this during the Star Party. But buckle up. It's going to be great. And figure out a way. I mean, obviously, we'll bring it to you in the Star Party. We will do everything we can to have a special Star Party where we just live stream the conjunction. But I think for anybody else, if you want to see this with your own eyeballs, figure out a way to do it so that you can see it, because it's going to be really special and you're never going to get a chance to see this again. When has there been a time when you've been able to see Saturn, Jupiter, Mars, Uranus, Neptune, Mercury, all in the same eyepiece, Venus? I can't imagine a time that would have happened, but it would be pretty amazing to see. But it's just there can be different versions of how close they would be. They might be all roughly in the same area as opposed to really tight, but this is just really tight. They're just going to be side by side. So anyway, about a month away. Stay tuned. It's going to be big. It's going to be I think it's going to be one of the big events of the year, of the decade. All right. Vegeta AFH. Hey, Fraser, do you think that nuclear power is a good option in space? So there's kind of two parts to this question. One is nuclear power as a propulsion system, and the other thing is nuclear power as an energy system, which could also be a propulsion system. So the one idea is to use like a fission reactor, like exists down here on Earth, but you put it in space and you use that to heat up some kind of propellant like hydrogen that you blast out the back of the rocket at a very high velocity. And this has been tested here on Earth, and it works really well. Very efficient, very high thrust, would shorten travel times, but the downside is that you've got to you got to be running a fission reactor that is blasting out potentially radioactive hydrogen. So it works best in space. So it might not work that well down here on Earth, or it will have health risks if you fire off too many of these nuclear rockets from Earth. But once you're out in space, space is huge. Who cares? So fire your nuclear rocket and blast your way across the solar system. The other method is to run a nuclear reactor to produce electricity. And of course, we do that down here on Earth. There are ways to do that in space. The Soviets back in the day launched a bunch of satellites with nuclear reactors on board, and they were proven to work. One crashed into the Arctic here in Canada. Didn't go over so well. The Americans, I think, have launched one. But for the longest time, it was sort of, after the sort of nuclear panic, people were like, okay, we don't want to, with like 3 Mile Island and things like that, people didn't want to have anything to do with nuclear reactors. And then sort of there's been a growing interest. And in fact, NASA in the last couple of years is starting to consider this idea of they call it the kilopower. And so a way to have a nuclear reactor that is reasonably portable and you could put on various places, like on the moon or maybe on Mars. And as you get farther and farther out from the sun, your ability to gather sunlight just goes down. You've got to have solar panels out at Jupiter that are like 25 times bigger than the solar panels that you can use here on Earth. Mars has, is less efficient than Earth, better than Jupiter. But really, Jupiter is the farthest you can go without some other kind, a nuclear power system. And so you could use an RTG, like what's on the New Horizons and Curiosity and those spacecraft, or you could use some kind of nuclear reactor that's producing the electricity, and it will work great. You just have to deal with all the risks of getting fissile material onto a rocket up to space safely, not have it explode in the atmosphere, et cetera, et cetera. So, there's absolutely some projects being worked on right now by NASA and other people to have nuclear engines function in space. And it's a very good idea, and it has some risks. So, like anything. I'm going to sneeze at some point. All right. VZAC is asking, will we be streaming the total eclipse on December 14th? Maybe. There's a total eclipse on the 14th? Huh. Okay. Maybe. I didn't know that was happening. So that shows you what I know. All right. So Horizon Brave asks, what do you think is the next stage for the next International Space Station? Do you think there will be a complete replacement, or will the current just be upgraded heavily? What do you think that looks like? So I think, tell me if I'm wrong, but the question that you're asking really is, what is the future of the International Space Station? Will it just be maintained? Will it be replaced? What's going to happen? So let me tell you what we know today, and then I'll try to tell you what I think where I think things are going to go. So right now, of course, you got the International Space Station. It was launched first parts of it launched essentially 2 decades ago. And since that launch, the first core modules were built by both the Americans and the Russians. And that's why it's the International Space Station. Since then, modules have been provided by the Europeans and the Japanese. And of course, the tremendous Canadian-built robotic arms that crawl all over the place and give you the thumbs up. And so this has been going for 20 years. And it is a machine. So like all machines, it wears down. And you could absolutely maintain it. You could bring up replacement modules, take out modules that are starting to fail, bolt in new modules, and keep going from there. Right now, there's kind of a game of chicken being played between the Americans and the Russians. Both keep saying from time to time that they're thinking of not continuing to maintain it. Who knows what's going to happen after 2024, and then after 2020, after 2024. I think right now there's commitments to maintain it until 2028. Who knows whether the Russians will be able to afford to continue maintaining their portion of it, whether the Americans will continue wanting to do it. And at the same time, plans are working to build the Lunar Gateway, which is the space station that's going to be flying near to the moon. So as the emphasis goes to building that, will that take away from any kind of maintenance costs in the International Space Station? At a certain point, they're going to get to the place where they're going to have to deorbit the space station, and it won't be a long time. Like, I wouldn't be surprised if in the next decade they decide it's time to deorbit the International Space Station, just like they deorbited Mir and previous space stations, and they'll crash it into the graveyard of the Pacific, and it'll be gone. The most expensive, most complicated machine that humanity's ever built, working for 30 years and then crashed into the ocean. And I mean, it sounds sad and tragic, but at the same time, its job was to teach us how to live and work and build things in space, and it did that job. And so it could be that there's much cheaper, much more effective, efficient methods. You build inflatable habitats, launch them. You can have the same, one Bigelow Aerospace 2200 has the same volume capacity as the entire International Space Station, and you could launch it on one Starship. Right? We talked last week about these things we'll be launching multiple times a day. One of those could contain a space station with the capacity of the entire International Space Station, and then 8 hours later, launch another one on the same Starship. So I think that they're constantly having this, considering the cost, considering the maintenance cost, and deciding what to do with it. And so they're just going to reach this point where it's clear that the space station is getting dangerous, that they're having more air leaks, that more of the oxygen scrubbers or the carbon dioxide scrubbers are going offline, that there's a death happens, and then it'll be time to bring that space station down. I don't think it makes sense to just keep maintaining it when there's just better technologies, techniques, new ideas, new hardware that can be built on the ground and launched. At a certain point, it'll be time for it to go. And there is another International Space Station that is being constructed right now, and that's the Chinese version of the International Space Station, and they are partnering up with various countries around the world to attach modules to their space station and for other astronauts to come up and visit them. So even if the International Space Station is no longer functional, there will be the Chinese version of it, which of course is, that's a hot potato politically, that I don't know how that's going to turn out. So anyway, I think 10 years from now, there will be a Chinese space station, there will be the Lunar Gateway, and there may be another American private space station. We'll see what happens. All right. Neko Girl, what are the chances of replacing Arecibo telescope? So again, since last week, we've learned that the National Science Foundation has decided to dismantle and decommission the Arecibo Observatory, and this is after the various failures that have happened. The engineers, when they were sort of working on Arecibo, when the one cable broke, they were assuming that the rest of the structure would be able to hold it while they could make repairs and keep moving forward. And then one of the other cables failed. And that told them that actually the damage, essentially the wear and tear on the entire structure is a lot worse than anybody was ever expecting. And so it called into question literally the state of all of the cables. And so then they're like, okay, do we go and replace every single cable in this entire system? And when it's very dangerous to do so, what are the risks? And as I think I mentioned this before, that Arecibo was kind of on a skeleton crew, very low funding, tragically underfunded for years. And it almost got canceled like a couple of years ago. So it's not surprising that finding out there's going to be a $100 million repair bill to completely rebuild it and refurbish it, someone just went, nope, nope, just it's over. And I think that's where they're at. So I don't think that there are any plans to replace it. And it's also not as necessary as it once was, because there are new observatories coming online. Of course, there's the Chinese. It's weird that we've got the same solution. There's the Chinese FAST telescope, which is 500 meters across. So it's bigger than Arecibo. It's the largest radio dish in the world, single radio dish in the world. But you've also got the square kilometer array coming, which is going to be an incredible radio observatory, although it doesn't have sort of the same exact characteristics. And then, of course, we saw with the Event Horizon telescope that you can combine the light from multiple telescopes around the world to act like a single telescope that's a lot bigger. So I think if Arecibo was the only radio telescope on Earth, then they would absolutely be repairing it. There are, I've seen some ideas from people that there are some pretty cool craters even in the United States that, old lava craters, old lava domes, things like that, that you could build a telescope in that would be roughly the same size or even bigger and get you that same effect. So who knows what'll happen? But I don't think that there's any chance at this point that Arecibo is going to be repaired and refurbished. I mean, I think they're going to keep running some experiments there. They're going to have the visitor center. They're going to have some other stuff that's there, but I don't think it's going to be a major science center anymore. Right. Let's keep going. All right. Bob Ohms. Fraser, why not at least let a satellite melt the ISS for scrap in orbit and turn it into trusses for a giant space telescope? That sounds so complicated. The problem with getting things up into space has traditionally been the cost of the rocket. You build a space station module for a couple of $100 million, and then you spend $1 billion to launch it into space. But now we're entering this time when you can launch something on a Falcon rocket for $60 million or a Falcon Heavy for $90 million. So the launch costs are coming down significantly. And that said, we don't have any technology for being able to melt down very complicated space, something space station, you just take the whole thing and melt it down into slag. It's aluminum and gold and copper and little pieces and plastic and all this mixed in. You're going to want to dismantle it very carefully. I can imagine a future where they, one possibility is they could raise the orbit of the International Space Station. But that causes risks as well, which is that now you've got the biggest piece of space junk up there that is no longer controlled, that could be broken apart, and then you've got just this spray of debris as it's just getting sliced and diced year after year after year, turning into more debris. So either use that station or get rid of it. And that's, I think, the decision they're constantly going to be making. So Kyle Kramer asks, what are your thoughts on Axiom Space's plans for a commercial space station? In case you didn't know, Axiom is planning to put a commercial module onto the International Space Station. And I think they've also talked about having their own space station. I think that trying to build a private space station right now is still a little premature until there is an inexpensive launch system. So even the Falcon 9, Falcon Heavy isn't cheap enough to make a truly commercial space station economically feasible. When you think about the expense that went into building the International Space Station, the costs that were involved to get the astronauts up there, it's really, really expensive. So I mean, right now it's going to be this sort of public-private partnership where they attach a module to the International Space Station and then they lease out parts of this for private use, private experiments, rich space tourists. But I think you're going to run out of rich space tourists. Once something much cheaper starts to fly, like, say, Starship, then you can readdress all of the costs. But right now, in the expendable launch market world, I can't imagine a completely private space station being economically viable. It's kind of like what happens with asteroid mining companies, right? They all just go out of business. So I'm not bullish over the short-term prospects of a private space station. Definitely, again, we've talked about this before. The second Starship starts to fly, and you can launch monster payloads to space for a couple of $1 million, everything changes. So until then. Eric 1, would they bring it all down at once or detach the various modules and deorbit them separately? Wow, we're just having, this is the International Space Station, the end of the International Space Station episode. So they would bring it all down in one piece. So there is a place in the Pacific Ocean, which they call the Pacific Graveyard. And it's the place that all the various space agencies try to crash their space stations into, or anything that can survive. Because with small satellites, they burn up in the atmosphere and they're gone. It's no problem. You can just let them just deorbit. Like when the Starlinks start to come back down, they can just burn up wherever they like and there'll be no risk to anyone on the ground. But if a satellite gets big enough, then chunks of it will make it through the atmosphere and crash randomly onto the Earth, which of course we saw with Skylab and every couple of years we always get another one of these scares when another satellite is about to come down. So you would just take the whole thing, just like Mir, you put a bunch of rockets on it and you would time things perfectly so that the whole thing deorbits nicely and goes straight into the Pacific Graveyard. You'd warn everybody to stay away from it and then it would just burn up. It would be incredible. Like when the space station burns up, it'll be a sight to behold and then it will just all go right into the ocean and then that'll be that. Down to the bottom of the ocean, there are dozens of chunks of wreckage of satellites and space stations. All right. Wow, lots of great questions. All right. Suvojit 168. Betelgeuse is not going supernova anytime soon. Are there any other candidates for supernova that can be witnessed from Earth in our lifetimes? Yeah, well, there are a bunch. Betelgeuse, we've learned fairly recently that Betelgeuse is actually a lot closer than we thought. And so it's not as close to the end of its life as we thought. And so maybe it's going to be an extra couple of 100,000 years before it actually explodes. So I know every time you see it, you stare at Betelgeuse and with your mind, you're like, come on, explode already. But it's probably not the most likely star to explode. The one that we think of that is most likely to explode is a star called Eta Carinae. And it's about 50 times the mass of the sun. And it is just about ready to explode. Like it can go any day now. And when it does, it's going to be absolutely visible in the sky to the southern hemisphere. And in fact, for a while there, it used to be one of the brightest stars in the sky, and then it became a lot dimmer, either surrounded by dust or maybe it, whatever was making it bright, it had flared off a bunch of times and has gotten a lot dimmer. But you can see some Hubble Space Telescope photos of like just the cool clouds of nebula around it, and it's, it really looks like it's about to explode. So that's the one that's probably going to go. But the one that happened most recently, the one back in the 1980s, supernova 87A, happened in the Large Magellanic Cloud. And it was about 170,000 light years away from us. And that is one of the most active supernova factories that we know of. And so it was no surprise that we saw one there. So I wouldn't be surprised if we see another one in that area before we see one closer to home here in the Milky Way, which is too bad because like I want to see another bright, really bright comet. I want to see a full-on meteor storm. I've seen pretty great auroras, but a supernova, that would be great. I'd love to see that. Yeah, Bill Sugden is saying in the chat, any day now means sometime in the next few thousand years. Yeah, that's what any day now, astrophysically speaking, is sometime in the next 100,000 years or so. All right. Okay, so Liquid Flames asks, I've always wondered how they managed to find signals from the Voyager and other deep space probes. Should I be imagining their signals as a line spiraling out or as a bubble expanding out from them? So when you look at the Voyager spacecraft, look at a picture of the Voyager spacecraft. They've got a... Oh, John Seffler, are you asking me about the Great Attractor? Oh, you're trolling me, aren't you? Okay. All right. So when you look at the Voyagers, they're mostly gigantic dish. And the big dish is what they use to communicate to and from the Earth. And even so, they have to have on Earth an even bigger dish, like a 90-meter radio dish to be able to receive the signal from Voyager, which is using its own dish that's as big as it can. They were able to launch with it. Same thing. If you look at all the spacecraft, the Voyagers, New Horizons, Galileo, Cassini, they're all dish. And that's the way they communicate. And so, yeah, it is absolutely targeted. That dish is pointed at Earth. And Earth's dish is pointed at Voyager. And then they are both putting out a cone of radio waves that are in the general direction of the parabolic dish that they're operating. Think about how, when you've got a satellite dish and you sort of have to point your satellite dish up in the sky, and then when you get it perfectly, then you can receive your television signal. And it's the same thing, except it's really far away, right? Light hours away from each other. And even so, the Voyagers their signal is very faint on Earth's biggest radio telescopes to be able to detect them. But yeah. So it's not like a laser, but it's also not like Voyager's just kind of sending out a circular or spherical ping in all directions. Amy Scott and Flower, you asked this question last week and I didn't get a chance to get to it, so we'll do it today. So would there be any way to add sufficient additional mass to Mars from somewhere else to give the planet 1 g of gravity and reignite its magnetic core? So let's think about your sources of mass here. So we know that the mass of Mars is like, what is it? It's about a quarter the mass of the Earth, 1/5 the mass of the Earth. I forget exactly. Apologize. Normally I have this stuff in my head. When I review the video afterwards, I'll get it into my head again. But yeah, and so it cooled down relatively quickly, and its dynamo internally stopped, and it stopped having a magnetic field. But you look at Venus, which has roughly the same mass as the Earth, and it doesn't have a magnetic field. It doesn't have a dynamo. So there's got to be something more than just whether or not you've got sufficient mass to be able to have a global magnetic field. It might be that it's the kinds of material, like you need to have a certain percentage of metal, you need a certain percentage of rock in your interior to generate that global magnetic field. So when you think about the raw material, you've got the asteroid belt. So you can take the entire asteroid belt, which if you did that, if you piled it all into one thing, you'd end up with about 5% the mass of the moon. You could take the entire asteroid belt, feed it to Mars, and it would barely increase the mass and volume of Mars, and would also sort of like liquefy Mars and turn it into just magma again if you tried to do that. So you need something more significant, like say Mercury. If you crash Mercury into Mars, now we're talking, but still that's not enough. You would pretty much need to crash Venus into Mars, or really crash Mars into Venus. And as we said already, Venus doesn't have a global magnetic field. So last week, I know you wanted to fix Venus. This week, I know you wanted to fix Mars. It can't be done. Just tear them apart, build the Dyson swarm. That's, no, I mean, what we should do is leave Mars as a beautiful, pristine wilderness that we can go and visit and enjoy it for what it has. Crazy chasms, mountains that are taller than anywhere else in the entire solar system. 1/3 gravity that you can use to jump around and enjoy. Just think about standing on one side of Valles Marineris and looking across and seeing to the other side and looking down kilometers to the bottom. It'll be incredible. So Mars sucks, but it's beautiful, and so it's fine just the way it is. And gravity wells are for suckers. Yeah. Eric, here's a thought. Let's fix Earth. Yeah. Let's prove that we can fix Earth first before we start smashing worlds into other worlds, trying to repair them. All right. Kyle Hunt, are you looking forward to the next data releases from Gaia? What are the implications? I love all these softballs. Yeah, I'm excited about Gaia. The Gaia mission, this is the European Space Agency's mission, and it's doing astrometry, which is like a really complicated word, but essentially it's tracking the position and the motion of billion plus stars in the Milky Way. And it's using that to figure out just like how the Milky Way moves around, how all the various individual stars. It's finding white dwarfs, it's finding neutron stars, it's helping figure out where the black holes might be. And one of the things that was really cool, we did a video about this, about showing from the one data release, they released essentially a data visualization of all of the stars that they knew of. And it looked like a photograph of the Milky Way, but it wasn't. It was actually just all of the points of the stars where they knew where it was. And it looked exactly like what you would see of the Milky Way in the sky. Incredible. And Gaia's just getting started. The next big update that we're waiting for Gaia is it's going to be using this astrometry technique to track the motions of stars that are being orbited by planets. So you're going to see a star, and it's going to make this tiny little circle in the sky. And that means that it's being yanked because of the gravity that's going, the gravity of the planet that's going around it. And it's expected, and this is the part that you just just let your mind roll with this, to find tens of thousands of planets. So we may find that in the next decade or so, we've got Kepler told us about several thousand, maybe TESS finds a few thousand, and then Gaia tells us about another 50,000 planets that people will go and observe. But the other part that's really crazy about it is that you've got, with all of the stuff from TESS and Kepler, you've got to have this perfect lineup. You've got to have star, planet passing right in front of the star so that we can see it. If the star is like a little bit above or a little bit below the planet, then we can't tell that there's a planet there using the transit technique or the radial velocity technique. But with the astrometry technique, you just look at it sideways. And so even if it's a little bit turned in different ways, I apologize for the people in the listening to the podcast. At many angles, you'll be able to detect this star being wiggled back and forth by the planet that's orbiting around it. And then you use that as targets for going after the direct imaging technique, which is what you're going to get from, say, James Webb Space Telescope or the HabEx telescope or things like that. So you're going to get this kind of 1-2 punch. You're going to get the next big data release from Gaia that's going to say, okay, everybody, here are 50,000 planets. Here are 50,000 stars with planets that we know of. And some of them are going to be close. And no one will have ever known that there are planets around these stars up until this point. And so they're going to be able to turn their telescopes, the extremely large telescope, the 39-meter extremely large telescope that's coming online in 2026 will be able to directly observe these planets. And so you think it's exciting now, but you're going to get this incredible data release from Gaia and other discovery of planets thanks to tests and direct and so on. And then you're going to be able to do these follow-up observations with these monster telescopes, with the extremely large telescope and James Webb and things like that, and see the planets directly as little dots, little blue dots, if they've got water on them, orbiting around a star. Like, right now, everything is just math, but we're about to shift into the next zone of looking for planets where we actually see them. And we're right around the corner now. Just hang in there. All right. Kaka Silva asked, I don't understand if a star is 70 years. If the star is 70 years, that means it exploded 70 light years ago when we see it. Correct. All right, so I'm going to try and sort of synthesize the question that I think you're asking, which is that when we see a star in the sky that explodes now, and if it's 70 light years away from us, then we know that it actually exploded 70 years ago. And that's correct. Everything that we see out in the universe, we're seeing backwards in time. When we look at the moon, we're seeing the moon 2 seconds ago. When we see the sun, we're seeing the sun 8 minutes ago. And when we see Andromeda, we're seeing Andromeda 1.5 million years ago, 2.5 million years ago. I forget how far away it is. 2.5 million years ago. And when we see the cosmic microwave background radiation, we're seeing the universe 13.8 billion years ago. And so you always have to remember that. And it's sort of like we're so used to everything we see being now, but then as we look farther and farther out, then everything is the past until we run out of time. And that's the edge of the observable universe. The edge of the observable universe is roughly the beginning of the universe. We can't see beyond it because we can't see before it. All right. Blue Jacket Warrior. Hey, Fraser, any new discoveries about the PRC space program after learning Chinese? Yeah, so I talk about this on a semi-regular basis, that I'm working on learning Mandarin Chinese and simplified Chinese writing. I finished book 1 of Remembering Simplified Hanzi, which is 1,500 characters. I'm working on book 2 now, Remembering Simplified Hanzi 2. Which adds another 1,500 characters. So in the next 3 months or so, I'll be capable of writing by hand about 3,000 different Chinese characters. I can read now pretty well, but I can read like fiction and where people are just talking to each other. I have, every now and then I've learned a bunch of stuff for space stuff, because that's the goal, is to learn space stuff. But there's a lot of really specialized terminology. So, but it is fun. It's kind of amazing now. Again, I've been at this for maybe 9 months, and like I watched part of the Chinese Long March launch today with the Chang'e 5, and I could read the rocket. I could read a lot of the text that was coming up on the screen while they were doing it. So it's kind of amazing to sort of reprogram your brain to understand what used to be just completely unintelligible to something that now I can glance at Chinese and understand what's being said. So it's kind of amazing. No insights. I have to, there's sort of this, I have to rebuild my news gathering system completely in Chinese, because all of the sources that I want to be able to get to have, you find it on WeChat, or you find it on Weibo, or you find it on various Chinese websites. And you have to be able to read this stuff and be able to navigate this stuff around and know which links to click and understand where to go and what to see. And then you listen to an interview, and you got to be able to listen to what people are saying and understand what they're talking about. And what they're talking about is very technical. So my guess at this point is, I'll be able to watch just like Chinese romances which are like the easiest ones. I've sort of parsed out all the text, and I find that like sappy Chinese romances are the ones that are the most accessible to me right now in terms of just understanding what people are talking about. And then I'm going to try to shift into news, specifically kind of science news, and build up all that vocabulary. And then be able to then shift into being able to understand fairly, science related information and be able to communicate. So I figure I will be useful for you in this capability. I'll have this capability come online in probably another 2 years or so. I'll be able to start doing some useful stuff in Chinese. So it's still gonna, it's a long haul. This is a tough one. So Avy Scott and Flower, Fraser low-key foreseeing the demise of the West and having to move to Asia when the CCP falls. No, I think it's just, I want to keep my brain active. And so I want to give myself a rough challenge, but also, they launch half the rockets in the world at this point. They're building a space station. They're sending missions. They're sending a sample return mission to the moon. They're going to be sending humans to the moon. It seems important to understand that language. So I think it's kind of fun. And Rich Wilson says, yeah, Fraser with Chinese, Pamela with Russian. We're doing well with the international. Six Bob Ohms is saying it would be cool to learn Indian too. ISRO is legit. Absolutely. ISRO is incredible. I mean, the work that the Indian Space Agency does is great. Fortunately for the rest of us, they do a really good job of putting out all their information in English. I mean, so they make it too easy on us by communicating in English and making it really accessible. Japanese would be cool too, but I'm not going to try and learn more languages. One is tough. All right. AAU, do you think that the TMT will be built at its planned location, and should it be? It seems like momentum is on the side of the protesters. Any other places where it could be built? So you're talking about the 30-meter telescope, and this is the telescope that was originally planned to be built up at Mauna Kea with the rest of the big telescopes there. And, they ran afoul of the of local people and local customs and sort of incomplete treaties, and it's a mess. And the protesters caused a lot of they brought a lot of light to the situation and made it a really big controversy that has now stalled the development of the TMT. It was the main thing that we were talking about when we were at the American Astronomy Society meeting in Hawaii earlier this year, like forever ago. And it was actually great. I got a chance to sit down with like one of the main people. I got a chance to talk to one of the main people who is like one of the local, not protester exactly, but sort of one of the local politicians, but he was Hawaiian origin, Native Hawaiian, and sort of had a really great nuanced view about what was going to be happening and why it was handled so poorly and what he thought it would take to be able to move everything forward. And I got a chance to talk to the astronomers and, sort of technically. And where I think we stand right now is I don't think it's going to get built in Hawaii. I think that it's going to, the alternate site is the Canary Islands in Spain, where, most of the rest of the northern hemisphere giant telescopes are built. And according to the astronomers, it's worse, but like a little less worse, or a little less good. Like, it's not terrible to put it in the Canary Islands. It would be perfect at Mauna Kea. It'll be fine at the Canary Islands. Good enough. And of course, Spain has said, bring it. Let's do it. We're ready. Sign these papers and let's get building the 30-meter telescope. So I think that at a certain point, the protests aren't going to go away. The getting it built wasn't handled well. and now they're paying the price. And I think it's going to collapse, and they're going to move it to the Canary Islands, because I think it just made, there's no controversy. It's still a great scientific site for a big telescope. I think we're going to see the Canary Islands be the main site of large observatories for the Northern Hemisphere. It's really too bad. I mean, the Southern Hemisphere sites in Chile are so good. The Northern Hemisphere just doesn't hold a candle compared to what they've got in the Southern Hemisphere. The Atacama Desert, which is like super dry, but also really high up, it's perfect. There's no other place on Earth that's as good. Well, okay, Antarctica is the best. If you want to build a telescope, you put it in Antarctica. That is the best place. It's just the worst place for humans to survive. John Suffield, can you see greater cooperation between various space agencies despite political boundaries between NASA, China, Russia, and ESA? I don't know. I mean, I think that we've now seen, 8 countries sign the Artemis Accords, and this is to define the rules for exploring the moon. So you've got Canada, the U.S., Japan, Europe, UAE. I forget all the others, but not Russia, not China. The International Space Station really wouldn't have gotten built without that international cooperation. It really required the capabilities of Russia, the capabilities of the United States, as well as the capabilities of other countries, as well as just more money to pay for everything to get built. And it just would not have gotten built in the scale that it got built without that international cooperation. But it's not necessary. It's helpful. And I think we benefit from it in terms of just peace and cooperation. And that makes me happy, but it's not necessary. And especially as the costs of launchers come down, it just doesn't make sense to build these giant cathedrals in the sky anymore. You launch an inflatable habitat and on a starship, and then 6 months later you bring it back down, fix it up, and launch it again. And I feel like I kind of keep going back over this, which is that our brains are not ready to comprehend what a incredibly inexpensive launch system is going to do for how access to space works. Right now, you launch the Hubble Space Telescope on the space shuttle. It costs you billions of dollars to build it. It costs you $1.5 billion to launch it. And then every time you got to repair it, it costs you $1.5 billion with highly trained astronauts to go up there and make repairs. In the future, you build a telescope that is 9 meters across, 18 meters long. It just sits inside the Starship. You launch it. It works for a couple of months. Then you pick it up back again with the Starship, bring it back home, upgrade it, launch it again. So it's going to be a different world. So, the level of international non-cooperation just in general makes me sad. Like, I do think that the world is made a better place when there are freer borders, when there's international trade, when people can live and work in different countries, that they're not bounded by where they happen to be born, where they happen to, whichever laws they happen to be born into. And I think that we should have more collaboration just across this whole country. The thing that makes the world the most peaceful place is trade. You're not going to want to go to war with someone because you do all this trade together. And I think that's one of the greatest sort of damping effects on people being grumpy with each other, is the fact that they depend on each other. And so more things that will make people dependent on each other, the better, I think. And if you can have that with space flight, that's cool too. So yeah, my preference would be everybody gets to go and be part of the Chinese space station and vice versa. And just to create these barriers I think it's short-term appeal, long-term decline. Um, let's see. I'm going to go back a bit. There's a lot of... Chris March is asking, how well is the quantity of mass energy in the no longer observable universe known? Remember, you made a statement in a previous recording about the quantity. I'm not sure. I mean, we don't know how big the actual universe is. We can only see the observable universe. So if there's whatever, 2 trillion galaxies in the observable universe, the actual universe might be infinite. And so it just goes on forever. And so like, what fraction is 2 trillion galaxies of infinity? I think it's, I don't think you can divide by infinity. So we know that the future accessible universe to us, if we could invent light speed tomorrow, or be able to travel just shy of the speed of light, then we could only get to about 6% of the entire universe, of the observable universe. So of the 100% that we can see, we can only ever get to about 6% of it. The rest is going to go faster and faster and faster and fall over the cosmic horizon and be gone. So we don't have a lot of the universe that we can actually travel to. Although it's an incomprehensible amount when you really think about it. But as a fraction of the total universe is not a lot. But I don't know how much. I don't think any of it has actually fallen over the cosmic horizon from our perspective yet. That was stuff we used to be able to see, but now we can't see. Let's see. Man, so many good questions. Chris March, is the extremely large telescope really a future-proof name? Did someone figure we'd only have a few more telescopes after that? There's a classic XKCD comic where they go beyond. You've got the very large telescope, the extremely large telescope, the overwhelmingly large telescope. And those are all real telescopes. And then you keep going on beyond that and all the future gigantic, terrifying telescope names. Six Bob Holmes is saying Sabina Hasselfelder worked out warp drive on Saturday, kinda. Yeah, I saw. So I saw that Sabina Hasselfelder, who is a very distinguished particle physicist and YouTuber and science communicator, did a video recently about what she thinks is a pretty legit idea for a warp drive, but she didn't share the paper. So I guess she only got access to the paper so far, and it hasn't gone in through peer review yet, and so nobody's had a chance to actually take a look at it. At the same time, Sabina Hasselfelder is legit. So if she says it's a cool idea, then it's probably a cool idea. But the rest of us can't talk about it until we get a chance to actually look at the paper. So we're kind of stuck. Watch her video. Do a search, Sabina Hasselfelder. Watch her video, and then as soon as the actual paper comes out, then of course we'll cover it on Universe Today. All right, we got like a couple of minutes left. So I just want to remind everybody that if you didn't get a chance to get your question answered here, definitely put the question in the comments, and I will try to answer a bunch of them afterwards. Not in the comments, the chat, because that disappears, but just in the video chat comments after, the way normal YouTube, that cesspool that you find on other YouTube videos. Post it there. Cabeza de Vaca. Fraser, would a telescope on Mars see that Hubble does not see? Nothing. There's no value putting a telescope on Mars compared to having a telescope in near Earth space. It's not like you're closer to anything. Maybe you would be closer to seeing features on Mars, but apart from that, maybe Phobos. If you had a telescope on Mars, you could see Phobos and Deimos really well. But apart from that, because you can build a much bigger telescope on Earth that would do better than the expense of building a telescope on Mars. There are some ideas to build a telescope on the far side of the moon. But that's, it's more about taking advantage of the fact that the moon has gravity, and you could go to the far side where it would be radio quiet. There's, of course, this idea of a 100-meter rotating liquid metal telescope on the moon. That's an idea. But yeah, to go farther than that, there's no better place to put a telescope than really close to the Earth. Except that there's this dust that's around the inner solar system, which you can see it. It's this stuff called zodiacal dust, and so as you look with a telescope, you can see this dust in the sky, and it's sunlight glinting off of dust in the plane of the ecliptic. And so if you wanted to have like the best telescope location, you'd want to get outside of the solar system, like maybe out to around Pluto or so, and then you would have a really clear dust-free view of the sky. So maybe that will be a future gigantic telescope, something out on Pluto. So maybe that's a use for Pluto. All right, we've reached the end of our hour. Thank you, everybody, for joining me this week. I really enjoy this. Of course, if you have any questions, comments, if you're watching this and you're like, man, I wish I don't have time for YouTube. Don't forget that I release the audio of all of these on my podcast. I'll put a link in the show notes, as well as, no, that's just it, podcast. So yeah. And I'll put a link in the newsletter as well. So if you forget about it, or if YouTube doesn't tell you that it happened, definitely make sure you check the newsletter, because I'll post a link to all the stuff that we do. You can go to universetoday.com/newsletter, and the podcast, just do a search for Universe Today on all your podcast things, and you will be able to find it. All right. Well, thank you, everybody. Thank you to the mods. Thanks to Nancy for posting all the comments over there. That was awesome. I really appreciate it. And next thing that's coming up is the weekly space hangout on Wednesday. All right. We'll see y'all later. Take care.